Okay, good, what is it? Good morning, everyone. So I'm Peter Hall. I'm going to be doing a WebTools update. So hopefully everyone has heard of our new WebTools and has used some of them. We have a show of hands who's used some WebTools. Who would pretty well half, maybe. We're slightly optimistic. So yeah, so this is just a sort of a general update on sort of some of the new features that have come on WebTools, and then some of them that you may not have found. They're sort of a little bit hidden. So yeah, so it sounds like most of you have found them already, but if you haven't, firmware.rgpilot.org/tools webtools, and if you're just on the firmware.rgpilot.org, you can sort of scroll down. There's a little WebTools button. So that will get you to this web page. Hopefully you can read that okay. If you're here, you might want to join the Zoom and sort of look at the screen share directly. So we'll start at the top and work our way down. So first of all, Log Finder. So this is a tool to find logs. You can pass it in a directory and it will list all the logs in the directory and group them by vehicles and sort them in various ways. The little caveat with Log Finder is that I'm afraid it doesn't work on Firefox. They haven't implemented the directory web stuff. But if you're in Chrome, it works nicely. So let's find our little example folder here. So I've just selected a directory. You have to give the web page permission. It's the new web directory thing. So you let it use all the files, and it takes a few moments and loads them all in. And there we go. So it's loaded in all the logs in this folder, and you'll see it's grouped them by flight controller. So there's some CUAV flight controller logs, and there's some CubeOrange Plus flight controller logs. So the idea, of course, is that each individual flight controller is a different vehicle. So you can point it at a folder with a bunch of different vehicles in, and it will find them. Then it just sorts them by date. And of course, it gives you the date, it gives you the name. If you hover over the name, it will give you the directory, because there could be a whole bunch of subdirectories that you've pointed it at. So you can figure out where that particular log actually is on your in your directory. Gives you the size, gives you the firmware version, the flight time, and a flight distance. One feature you may not have noticed is that if you hover over the flight distance, it will load a little map. So quite often, you'll have a bunch of sort of little logs, and you'll think, oh, what was that log where I did the big mission or did something else, and you can't find it. Well, you can just skip through all these little maps and figure out which one it is you want, the one where you did the mission. Or I think if we go to the bottom here, that's from flying about, more flying about. One of these is a mission. That one's probably a mission. So this is Matt's flying, and he can't fly in straight lines, so that's a mission. So that's useful. It also, if you've done a whole day's flying, you can work out the total flight time and the estimated total flight distance. That's quite a nice one. If we're out flying for a day with a customer's vehicle, we say, oh well, we've flown 20 kilometers or whatever today cumulatively. The other nice thing is it tracks parameter changes. So this is parameter changes between the log files. So you'll see on this flight, we changed the Excel limits. On this next one, it looks like we have done some notch setup, more notch setup here. This one, we obviously, it looks like we updated from 4.1 to 4.06. So there's all these new parameters have turned up. So this is useful quite often. We'll be doing a bit of testing and think, oh, well, we had it working really well about 3 flights ago, and now we've gone a bit too far and ruined it. So you can go back and say, whoops, we can put those back straight away. So it will give you new parameters. We'll also give you, if you scroll down, we'll give you changed parameters. So if it's a changed parameter, it gives you the original value and the new value. So that is useful for basically, if you're out doing setup for a day, you can figure out where you went wrong. If you just want the parameters, you can click the parameters button and it'll just download the param file for you. So again, that's useful. Just to extract the parameters, you'll notice these logs at the beginning have got this orange exclamation mark. That's because arming checks are disabled. So don't do that. Please enable your arming checks. You will also, if you have like a Watchdog reboot or there's a crash dump in the log, you will get a little red exclamation mark. So if there's a little exclamation mark, it's basically go and have a better look at this log and see what went wrong. There's also the open in button. So this is sort of a side entry to all the other web tools. So you can take this log to one of the other tools. So we could do, open in hardware report, and it does what it says on the tin. It opens in the hardware report. Again, arming checks are still disabled. Don't do that. So that's got a little bit nicer. You'll also notice on some of these, for example, here, filter review is grayed out. So that's because the right log messages are not present in the log. So it'll only let you open in tools that should work. So again, that if you've got a whole bunch of logs and you're not sure which one was your filter flights, you can use that to quickly find the log with the correct information in. So yeah, that's log finder. That is if you've got more than one log, this is the tool I start with, and then use this to get into any of the other tools. I think our record is about 3,000 logs looked at in one go. Takes quite a long time to load, but it will do it. So that's a log finder. Let's see if I've everything. Oh, sorry, not Safari either. Sorry, Mac users. Yeah, I think we've covered everything on my little list for log finder. So hardware report. So we'll just pick one of these logs and take it over to hardware report. So of course you can also, if you go back to the WebTools landing page, you can also open hardware report sort of directly and then pick the log manually. So there we're back on hardware report now. So this is the log. So first of all, it tells us the firmware version, and it gives us a warning, not official firmware release. So this is handy. It will tell you if it's like a stable or a beta release. It just searches GitHub for all the tags. And it's not official firmware release, but it has managed to find this commit. And if we open the commit, it will sort of give you a clue. So in this case, we were testing some of Matt's auto rotation stuff. So it's pointed us at this commit, which is to do with auto rotation stuff. So again, if you're running custom code and you've forgotten what branch you're on or something like that, this will give you a bit of a clue sometimes, make it a little bit easier to find exactly what branch. I've got about 800 branches and quite easy to lose stuff. It tells you the flight controller and the flight controller unique ID, and it double checks that the board ID, so your board ID should match what the flight controller thinks it is. If it doesn't match up, it might not match up on somewhere like the FMUV3 boards and things like that. If you have an IOMCU, you'll get some IOMCU errors. People often come and ask me, I've got a red cross for IOMCU, and they'll have like one error. You don't need to panic for one error. If you've got hundreds of errors, then it's might be worth looking into. Got the IMUs displayed here, and in this case, they're healthy. So all this healthy check is, it just looks in the log, and if every time there's a log, it's reporting healthy, you get a tick. If there's just one instance where it's not healthy, you get a cross. And again, it's basically go and have a better look at this log. A cursory look may not be sufficient in that case. Got our compasses enumerated, barometers, airspeed sensors, and if it's a drone can airspeed, in like this case, it actually gives you the name of the drone can node. So if you've got a whole bunch of or sensors, you can work out which one's which. Drone can devices. So we knew about that airspeed sensor. So there's the airspeed device on the drone can bus. We've also got this rangefinder device. And again, you can see it also does the like firmware version lookup for peripher devices. So the airspeed sensor is on the peripher stable branch, and it'll link that for you. So you can go and find exactly that branch. But in this case, the rangefinder is not on a stable branch. And again, it's found a commit, and it's, what is it? Oh, it's adding a second rangefinder instance to peripher. So not only can you track the firmware version of your main flight controller, it will also do the peripher devices for you. And it also tells you the driver, so driver 0 in this case. So that's useful if you're, if you've got hundreds of CAN devices, you can just make sure they're all on the right version and things like that. You can download parameters. You can either save all of them or just the changed ones. And then this minimal configuration thing is quite powerful. It lets you ignore sort of calibrations and RC calibration, Excel calibration, compass calibration. So all the stuff that you shouldn't transfer between vehicles, you can ignore and just save a minimal param set. And for most vehicles, it'll get you down to actually, 100 sort of key parameters. This is the tune. It defines sort of the layout of the vehicle, but not the calibrations and sensors and things like that. So that's useful. Quite often a sort of first thing I'll do is save a minimal parameter and then just look through these by eye and go, oh, is there anything I wouldn't have expected for a particular vehicle in this sort of minimal param set? It also will extract waypoints. So there was that square mission. So if you want the mission that you ran in a particular flight, you can come here and download it. It will do that for geofences as well. So if you've got a polygon geofence, you can extract that, and then you could load it onto a different vehicle. Does the sys file systems. So for example, you can download storage.bin and just copy it into SITL for running SITL with exactly the same config. It will show you position offset. So this is useful if you've got a big vehicle, you might have set position offsets for the GPS and things like that. And this just shows you in a 3D plot. And you can double check, oh yes, GPS 1, I was expecting that to be at the back. And then everything else on this vehicle's in the middle. But that's just handy because the sensor position offsets can be a little confusing. So what we tend to do is set them manually, then we'll save the log, or you can save a param file and load it into this and just double check, oh yes, GPS 1's on the left, GPS 2's on the right, things like that. Temperatures, this is basically all the temperatures that are available. Nothing too exciting here. Again, it's just hardware issues. So if you see these spike uploads, then maybe something's gone wrong. Board voltages. So again, lots of spiky noise is bad. It will also, if you zoom in on the MCU, it does give the bounds of the MCU voltage. Load, nothing too exciting. Free memory loop times. So you just want to double check you're getting roughly what your the worst is, not too far from the average if you've got massive dips in here. That's bad. Something new that's coming in 4.6 is logging of UART data rates. So this will plot data rates for you. And then it also plots sort of the limit. So for each baud rate, there's a maximum data rate you can achieve. So that's in the dotted line here. And then transmit and receive are plotted here. So that's for each serial port. So Mavlink, this has got FrSky pass through. So it's receiving, and maybe these sort of dips are depending how close you are or something like that. So you could try and figure out why you're losing data. GPS is nice and steady. Another Mavlink, not receiving hardly anything, so it may not be connected. And that's the internal serial connection to the IO MCU on board the flight controller. Does the same for drone CAN. So you can see sort of how much of your available bandwidth it's using. I will asterisk, this is a sort of, or the limit here is a sort of pessimistic limit and idealized and stuff. So it may not be exactly right, but it will provide you a sort of estimate of how much of your drone CAN bus you're using up. And if you can fit a few more devices on, or if you better turn down some data rates. some stack stuff that's usually not that exciting. Some plot of drop log messages, so it's 4.6. So Peter Barker's been doing a lot of work, and now it's 0. So hopefully this plot will get so boring we remove it in the future. Also gives a split of the log file. And a new graph we've added recently is clock drift. So this is a comparison between the like crystal on the flight controller versus GPS, logged GPS time. So something like this is fine. If you see a big slope going off in either direction, maybe have a look at your crystal. Question? Oh, yes. Oh, there's a video. No, this is recorded. So a sort of ongoing job for me is to add better documentation. You'll see some of the tools have got like pop-up tool tips and things, and I just haven't had a chance to add them to everything. So a suggestion from Ryan that I add some examples of sort of this is good, this is bad. So yeah, more documentation needed. So I think we've ticked off everything on my list here. Yep. So the next one down in our list of web tools is MagFit, and I'm afraid there hasn't been a huge amount of change there since I first released it. So MagFit is the same as it always has been, and when I released it I did a blog post. So if you want to learn more about MagFit, go and read this blog post. It is on my list to do some MagFit updates, but haven't got there yet. Filter review. So this is probably this is sort of the original web tool and the one that perhaps has used the most. So again, if you haven't used it before, there is a blog post. So you can go and check out this blog post. But we will also just have a quick look at a log. There we go. So that's loaded in. So a few updates. First of all, on 4.6, we've added some new raw IMU logging options, and they're outlined on the wiki. But if you have sort of the bandwidth for it and you're logging, it's nice to use the new INS raw log options to get raw logging of either just the primary gyro or however many you've got. This is nicer than the old like raw IMU logging that used to be in log bitmaps, because it only logs the gyro. It doesn't also log the Excel, which means you get smaller logs and it can keep up. Although you might find it kept up for a little bit, but for example, the new Cube Orange Plus balanced gyros, all the IMUs are running so fast, the logging doesn't keep up anymore. But you can do primary only on that with the new raw log options. So this is a raw log, and the reason it's better is because there's just much more data. So you can see we get a lovely spectrograph here with lots of time resolution. Yeah, if you have the bandwidth, raw IMU logging gives better results in the filter tool. So you will notice a few weeks ago this new filter version checkbox appeared. So it defaults to version 1 if it finds, or if in your log you're on a version that is using version 2, it will default to version 2. So the filter version is we changed how we dealt with notch filters at low frequency. So as they get to the minimum frequency, they fade out on filter version 2, which is much nicer for things like planes and quad planes. For those of you with copters, it amounts to about the same. So if you have, for example, an older filter log from when you first did your filter configuration, that although the code from that log is not using filter version 2, you can still select filter version 2 here in the tool. So you don't necessarily have to go and redo all your filter flights. You can actually use an older log from when you first set up your vehicle to just double check. So you can just select that up here. This is one of the tools with the lovely question marks. So if you see question marks, go and hover over them. And I've tried to add a little bit of extra information. What else is on my list? So it's a good idea to just come and have a look at the spectrograph and make sure it's sort of fully filled in like this. If you're dropping log messages, you'll see like white bars. For example, if I zoom out on this, you see there's a big white bar here, and that's because it dropped a bunch of log messages on that IMU. So if you've got done a filter flight and you've got lots of white bars in it, it means you're dropping logs. So it might be worth turning down some other logging options, or perhaps you have to go back to batch logging or something like that, because or lots of missing data means the sort of averaged FFT results are not as reliable. So the other thing I wanted to just highlight is when you're using raw logging, you get this option to change the window size. So you'll see by default we use 1024, and then that will give us frequency resolution. So the tool here tells us the frequency resolution. So it's 2.2 hertz in this example. And you'll see we have a nice, if I just turn off those notches, you'll see we have quite nice time resolution. But you can turn up your window size. So if I go up to say 8,000 and hit calculate again, you'll see now we've got a frequency resolution of 0.2 hertz, and you'll see all the lines here look a bit more jaggy. But in the spectrogram, you'll see it's all sort of smoothed out. So you can use this window size to trade off between frequency resolution and temporal resolution. So quite often, if you've got a nice steady hover, we might sort of zoom into this hover a little bit more carefully, and then turn up the window size for looking at this sort of averaged FFT to sort of set up your filters. And then you might turn down the window size again. So go and look at the spectrograph and see how the tracking is getting on. So you can use the sort of time resolution to see how well you're tracking down as we go up and down throttle or something like that. So that is a sort of nice one, and that's one advantage of the raw logging. You don't get that flexibility with the batch logging. So the other thing is that now in 4.6, you can enable multi-source with throttle-based. This is some work Andy and Leonard have done, so that you can do per motor tracking with a throttle-based notch. So you get some of the advantages of having sort of per ESC feedback without actually having to have per ESC feedback. So I just enabled that by ticking multi-source. So it will give that page unresponsive warning occasionally. You just have to chill out and wait a little bit. So now if we zoom in, we'll see for each of these harmonics, we actually have 4 lines. So this was a quad. And you'll actually see in this case, the per motor tracking is actually a nice benefit, because there's actually quite a big split between motors in this case. I think there was a bit of a pitch imbalance on this particular vehicle. So because there was a split between the front and rear motors, the per motor tracking is a better advantage than it would be on a sort of lovely balanced copter where all the motors are often very similar. You will see that the tracking is a little bit coarser here because we can only recreate the sort of throttle signal from the logged RC, which is only 10 hertz. So it's a little bit, or the displayed tracking is not as nice as for some of the tracking sources which are logged faster. But on the vehicle, obviously it runs at the full rate. So I think that is all of the new features for filter review. Any questions on filter review stuff? I guess you all understand it. There's one. Oh, no. So Matt reminds me to just point out this phase and gain plots. So this is the phase and gain of the configured filters. So if you remember the original filter tool that was presented at the conference last year, this is sort of uh, the version of this with filter tracking. So the solid line here is the average, and then the gray sort of shadow is the extreme. So as the filters track up and down, that's the sort of range of the gain and phase. So this is handy for comparing. You know, you might have a few different settings that you're considering. You can come down here and just sort of see how that looks for phase. The key thing is not to have too much phase lag. I think really the sort of, or my sage filter advice is not to get too obsessed with, you know, turning up the resolution loads and going after every single peak a bunch. A sort of a light touch is better than going too hard on this stuff. And I think, or being able to look at everything in this detail, sort of people tend to go after everything really, really carefully, and often that's a step too far. So PID review. So PID review is sort of the same idea with frequency domain analysis, but for PIDs. To get the zoom thingy to go away. So again, you get the sort of flight data plot. You get a time domain. So this is what you might be used to, you know. If you go and look at the rate message manually, you'll see that. I think I've picked a bad example log because this is only a 10 hertz logging rate. So you really do need a log with full rate logging to make the most of this. That one looks better, 400 hertz logging. So you get the target and actual in the time domain, and it will also plot that in the frequency domain. It makes an attempt to estimate a step response. It's not very brilliant. There are other methods of doing similar things that will be presented later in the conference. And again, you get your spectrograph, so you can sort of see maybe this is noise sort of sneaking underneath the notch filters as the rotors run down at the end here. So that gives a little bit of an insight, and we do have some new for 4.6 PID notch filter options. So you might use a tool like this to decide exactly where your PID notch might want to go. This isn't clever enough to do the sort of pre-post, but Bill will be presenting on a tool that is a little bit later on. It will also, if you change parameters during the flight, it will split into groups for you. Let's go back to my list. So filter tool is essentially unchanged from how it was presented at the conference last time. You may not have found at the bottom, we've got a little work in progress section. So there's a few tools that are either sort of still under development or they're a little bit more dev focused, a little bit less polished. So if you go to this work in progress tools, we've got quite a few now. And I think I will just hit on a few of those quickly. So there's stream stats, which let's close some of these tabs. Stream stats is basically just for looking at either log files or T-logs. It gives you data rates, messages per second, and then splits up what percentage of the log is each thing. So this is handy if you're if you want to know what rate your logs were coming in at, or if you are analyzing a telemetry log, you might find that all the message rates go down when the vehicle's far away, things like that. That's stream stats. We've got kinematic tool. So this is just a visualizer for the attitude control, angle and rate input shaping. Basically, I was trying to understand all of Leonard's code. I thought best way for me to understand it is to write a little thing that does some plots. So it's useful for understanding code. The other thing it's handy for is you want to set, particularly for you want your rate target to be sort of in the same order of magnitude as your acceleration. You don't want it accelerating for ages and then it'll take ages to slow down. So you can use it for things like that. So you can set initial conditions, you can set desired angle. So if I turn it to rate mode, we can tell it I want it to rotate at 60 degrees a second. You'll see it accelerates for some amount of time, then it flatlines when it reaches 60. And obviously, if you had a much smaller rate limit, you'll see it takes longer to accelerate. So sort of it just gives you a little feel for things like that. I think the rule of thumb is about half a second you want it accelerating for.
Half a second is nice, but very slow aircraft, 1-1 would be okay, but I don't like going under 1-1. Half a second is great.
Yeah, so those on Zoom, Leonard says about half a second, maximum of 1. So this just is a handy tool. You can sort of just get a feel for how the parameters sort of define how the vehicle will respond. This geofence generator. So I have it preset here at the hotel. So this is really for boats. You can search an area on this map here, and it goes off and does an OpenStreetMap request, and it will generate all these fences for you. So you can see all the different water bodies here. And in fact, I think if I go up here is the lake we're going to this afternoon. So if I do a search in this area, there we go. So we can then download this lake. And then if I come into Mission Planner here, I can load that in. And then we have that lake as a nice geofence. And it even does exclusion zones and things like that. So that is useful if you're doing boats. I basically got bored of tracing out lakes and things.
We have a geofence in our permits, technically around, there were not a lot of islands. How big could the area be in which to make the geofence? If we wanted to make a geofence in the whole archipelago of Gothenburg, for example.
So the tool sort of limits the number of points, but the actual fence itself can be as big as you like in area. But obviously, as you get into a bigger area, the resolution has to go down, because Archipelago, I forget what the limit is, but 200 or something like that points for a geofence. Especially if you're doing things like Dijkstra's based on geofences. Obviously, the bigger, I think Dijkstra's is n squared or something. So bigger the fence, the longer it takes to calculate. So yeah, at the moment this is only water bodies, but we could. It's sort of a GeoJSON to geofence. So I know, or we might find that some of the new regulations provide GeoJSON files for like keep out areas and things like that. So eventually we might be able to integrate that into a tool like this that provides the files for you. The other little feature is that you can press this crop button and it gives you a sort of corner. Maybe you're only allowed in a corner of a lake, or you've got an enormous lake, and if you were to generate the whole thing, you would lose a bunch of resolution. You only want to go in the corner. So we could just cut it down to this bit. And if I download that, it will we just get the corner there. And you might notice that we get a bit more resolution because we sort of have more points we can spend in the smaller area. So that's the geofence tool. We got next rotation check. So this is a very handy one if you're not sure what orientation to put your AHRS orientation parameter at. You know, you've stuck your flight controller on at some wacky angle. It gives you a selection of all the built-in, gives you the base vehicle is the small arrows, and the big arrows are the as what the flight controller will be mounted at. So you can do, you know, all the boring ones. You can also do custom and put in, custom numbers. So again, a sort of handy thing. I sort of saved me holding a flight controller and thinking, oh, re-roll, and then you sort of time yourself in knots trying to work it out. So this is a sort of, again, a sort of double check tool for that. And at the bottom, there's three new web tools, and each of those has their own talk coming up. So don't click on any of them. They're all live. You're not allowed to look at them until after the talks. So I think that is my highlight of the existing tools. I would just like to give a quick overview on the dev setup. So we're getting a few more contributors to the web tools, and it really is very easy to set up the dev setup. It's 2 Git commands. So there is a README, which tells you how to do the setup. So you clone the repo and you do a submodule update, and that's you set up with the dev environment essentially. I'm afraid the submodule update takes ages. It's about 13 gigabytes. And that's because lots of the tools will work offline. So we use local copies of libraries and things where we can. So you can just clone and set up on your laptop and go out to the field with no internet at all, and the tools will mostly work. Some of them, like the geofence one, won't work. It needs maps. The GitHub, like firmware version lookup, doesn't work. It needs GitHub's API. But for the most part, all the tools work offline, and they're all completely run locally. So if you upload your log file to one of the tools, it doesn't go anywhere. It's still on your laptop. We don't collect it or anything like that. It's all local JavaScript. And then you just need to host once you've done your clone and submodule update, you just need to host it. You can use this little one-line Python. If you're in VS Code, there is a VS Code extension called Live Server. So if you install that, you can just, there's a go live button. You hit go live and it goes live. So this is now on the local copy of my repo here. And to prove it, if I can press the button that's under Zoom, if I go to the home page here, so it spelling mistakes and all, a lot of updates, the web page. So that's handy. Of course, if you need to do debugging, you can do debugging in your browser. So function F12 is usually what you would press in your browser. You can jump into here in the source tab and put in, breakpoints and things like that. So if I now, here's my example folder gone. I can now, do step-through debugging here in the browser. So it's really sort of you all have the dev environment installed already in your browser. The thing I recently added, if we just stop that, I also added built-in debugging options with in the VS Code environment. So you can go host with live server extension and debug with Chrome. So if I click play on that, it opens a new Chrome instance. We don't need that one, which hasn't immediately worked. Let's try host with Python. There we go. So now I can, if I go and find the right file, I can go and put in breakpoints here in VS Code, which might be a bit more familiar to some. So I'm in Blog Finder, I think. I wonder if this will. There we go. So now I can do step-through debugging in VS Code. So that's that. and it's that live server extension is really useful if you're using VS Code. So in the future, we talked a little bit about those top secret tools. So there's the SysID new analytic tune tool, which Bill will be giving a talk on. There's new telemetry dashboard, which I'll be giving a talk on, I think tomorrow. Future work, I talked a little bit about MagFit. So I want to implement a new approach for MagFit, which should get results a little bit closer to the existing Python-based MagFit. I'd like to add PID review, allow that to compare over multiple logs rather than just one log. Be nice to make the kinematic tool do like position control. At the moment, it's just attitude control. So I'll add that sort of up the next level there, position control and S curves. Ideas for new tools. So if anyone's got an idea for a new tool, these are a few I've had. Obviously, sort of auto log review is sort of the big one. Would be, you know, hardware report does sort of hardware-y things, but to do a sort of a tool that will automatically look for in-flight issues, obviously that's quite a big job. Another one is to calculate thrust expo from thrust 10 results. So we've got a sort of example Google sheet for that, but it's a little bit tricky to use sometimes. So maybe a tool for that. Yeah, but I mean, if anyone has any ideas for web tools, I'd also urge anyone who feels like writing a little thing in Python to hold back and go and write a web tool, and then we can all use it. So yeah, any ideas for new tools? Any questions on existing tools? No. Oh, one. Oh, two.
Is there a tutorial on like easily adding the graphs and making it look like the others for those of us who'd want to do a new one?
There's no tutorial, sorry, but it's all very easy. You can copy and paste. The one big advantage of web development is you can Google it. There's hundreds of examples online. For example, the plots are with Plotly. Plotly
What's
has
the
a
simplest to copy and paste from?
it depends what sort of thing you're trying to do. You sort of pick the one that is closest to the thing you're trying to do and copy that as the starting point. Yeah. Yeah, developer's secret, copy and paste.
Japanese 日本語で質問したいので、川村さんかランディさんにトランスファーお願いしたいと思います。よろしいですか？はい。2つクエスチョンあります。一つは、ログファインダーでパラメータを変更したたくさん、パラメータを、リアルタイムにチェンジすることがあります。その時に、ヒストリーが見れるかどうか。
Yeah, so if there's a lot, it will. Because I've been messing about, I've broken my local copy. Oh well, yeah, yes. So it will show. It shows the like between each log as it's sorted, and then at the bottom it will show you between the first log and the last log. Yeah.
Thank you. Two questions. GPS ロケーションと、POS、EKF のポジションが、比較したいときがあるのですが、同時に見れますか？
So not in these tools, but you can plot that in, for example, like the usual UAV log viewer will plot that for you. You can do it in Map Explorer. I'm afraid you have to sort of go back to the manual tools.
もう少し難しいんですけど、このUAV ログビューでそういうことが。
OK。わかりました。ありがとうございます。Thank you.
Thank you.